When most of us think about AI, our minds probably jump to chatbots, right? Or maybe generating some crazy images. But what if AI's next big leap isn't on a screen at all? What if it's on the factory floor? Today, we're diving into how AI agents are being built to manage the massive, complex physical systems that power our world.
So to really get why this is such a game changer, we first have to talk about this huge, kind of invisible challenge that modern industry is up against.
Just stop and think for a second. Every single time you stream a movie, send a quick email, or scroll through your feed, you're tapping into a data center somewhere. And those places, they generate an incredible amount of heat. So what's stopping them from, literally melting down?
Well, the answer is these massive, super complex industrial assets, things like data center chillers. They're the unsung heroes, really the absolute backbone of our digital economy. And they need constant expert attention to make sure nothing goes catastrophically wrong.
Here's the catch, though. The human experts who are in charge of these critical machines, they are facing an absolute fire hose of data. The amount of information flying off this modern equipment is it's overwhelming.
And to put some numbers on that data fire hose, just to see how wild it is, just a handful of these machines can pump out over 2.3 million sensor data points that someone has to keep an eye on.
On top of that, an engineer has to take all that live data and check it against 53 different documented ways the whole system can fail. And each one of those failure modes has its own little signature hidden in all that noise. And if they need to look back for context, they might have to dig through more than 4,200 old maintenance work orders just to try and spot a pattern. So you can see how this all stacks up, right? It's just not humanly possible for one person to juggle all of that. The live sensor readings, the technical manuals, the maintenance history, all at once. Trying to connect all those dots to stop a problem before it happens, well, that's a truly superhuman task. So, how in the world do you solve a superhuman problem? Well, the answer coming out of IBM research isn't some single all-knowing AI. Nope. Instead, it's more like a coordinated team of digital specialists, a crew where each agent has its own job to do. Okay, so check out how this actually works. A human engineer notices something's off and asks a simple question. The main agent, it's like the project manager, instantly assembles its team. One agent goes and grabs all the live sensor data. Another one pulls up the machine's entire maintenance history. A third one analyzes all of it for any weird patterns. Then they all share what they found to pinpoint the real problem. It's brilliant, because it does what a human team of experts would do, but at machine speed.
Okay, but let's be real. You can't just hand over the keys to a multi-million-dollar data center to a team of AI agents and just hope for the best, right? You have to know for sure that they can handle the pressure. You've got to test them, and test them hard.
What the researchers really needed was essentially a flight simulator, but for industrial AI. A safe, virtual space that was realistic enough to train these agents for the incredibly high-stakes work they'd be doing out in the real world. And that is exactly what they built. It's called AssetOpsBench, and it's the very first proving ground of its kind, designed specifically to see if these industrial AI agents actually have what it takes. We're not talking about some simple test here. This simulation is incredibly deep. It uses real industrial data from multiple sources and throws over 140 different scenarios at the AI, scenarios written by human experts to mimic the exact kinds of problems real engineers have to solve every single day. So with this amazing testing ground all set up, the researchers could finally put these agents to work and see what really makes an AI team effective when the rubber meets the road. They basically tested two main strategies for how the AI team could think. The first one, tool as agent, is really flexible and reactive. It kind of figures things out as it goes. The second, plan and execute, is much more methodical. It makes a full step-by-step plan up front and then just follows it to the letter. And when they ran the tests using that more flexible tool-as-agent approach, a pretty clear performance ranking started to show up. The most powerful large language models, like GPT 4.1, came out on top, managing to successfully complete about 65% of all the tough tasks that were thrown at them. And this is where it gets really interesting, because it highlights this critical trade-off. Sure, the structured plan and execute strategy was faster, it took fewer steps, but the flexible tool-as-agent strategy was way better at actually getting the job done right. And in a world where one little missed detail could cause a system-wide failure, you've got to go with what's most effective.
So, what does all of this actually mean for the industries we rely on every single day?
Well, what we're looking at here is a pretty fundamental shift in how we manage our physical world.
The biggest insight from this research is, well, it's powerful. For these incredibly complex, messy, real-world problems, you don't need one single super genius AI. You need exactly what this paper is talking about, a well-orchestrated team of collaborating specialists. This isn't just some cool academic project. What we're really looking at is a blueprint for building more reliable, more resilient AI systems that are designed to manage the critical infrastructure that powers everything, making sure the lights and our data centers always stay on.
And that leaves us with one final, really big question to chew on. As these AI agent teams become the new frontline managers of our infrastructure, what's the new role for the human expert? Are we the conductors of this digital orchestra, the strategic thinkers, or something else entirely? That's the new landscape we're all just starting to explore.